So this is for chapter 8. So you might have a question like this. This means you just have to write this in a symbolic way. For example, if they say the mean weight of male is equal to 69.2. Okay, for example, if you have something like this, then you will have three boxes here. You can see this in your MLM assignment, and you will have a small arrow next to the first two boxes. Okay, so here you will have symbols like this. If you click on the arrow, you will have symbols like this, and I guess this one. Okay, now when your example says mean, you're going to pick this symbol, right? You're going to pick that symbol. Okay, now next to that, in this small box, you will have symbols like this. Now, which symbol you have to choose, it depends on the question. Now here, according to this example, it is equal to. According to this example, it is equal to. So I'm going to choose this symbol for here, right here. Okay, so it will be mu equal to. Now here, you have to write the value, whichever is mentioned in your problem. Okay, so this is your section 8.1 first question. So in first question, you have two sub questions. This is that part A, and for part B, it is just to identify null and alternative hypothesis. You know how to do that. Okay. Now after this, most of your section 8.2 is identifying null and alternative hypothesis. Okay, all, like, I guess most of 90% of your questions is this. Now after this, you might have one more question which will ask you to check for the accuracy rate. Okay, is the accuracy rate acceptable? So how can you decide on this? So this mainly depends on the p-value. Now when you compare p and alpha, if your p is greater than alpha, you are going to say fail to reject. Now if you say, or if your conclusion is this, fail to reject, then I say that accuracy rate is acceptable. Fine. Now, what do you mean by accuracy rate? Very simple. That means your claim. So that rate will define how much your claim is correct. Okay, that is meant by accuracy rate. Now, when we say fail to reject, that means, in other words, I say you're not rejecting the H naught, you're accepting that. So when you're accepting H naught, that means your claim is correct. So your accuracy rate is acceptable. Okay. And these are the only questions which I found you might struggle. So most of your questions are direct. Done? Okay, so that's your chapter 8. That was your chapter 8. Now, do you have any trouble with your lab 8? No, right? It's easy actually. Okay, so then let's get started with chapter 9. So this is actually chapter 9. Small correction here. is chapter 9. Now, in this chapter 9, it is like a continuation of your chapter 8. So, in chapter 8, we were dealing only with one proportion, one mean, one sample size, everything was one. So, in case of chapter 9, we will be dealing with two proportions, two means, two populations, two sample size. Okay? Okay. So, I'll just recall what is independent and dependent sample. Now, when it comes to independent sample, you say two samples are independent when their sample size is different. Okay, when sample size is different, very simple. You will have two proportions or two population given. Now, depending on the sample size of each population, you conclude whether it is independent or dependent. Okay, now when it comes to dependent, that means sample size are same. Are same. This is sample size are different. Okay. Now you have a small example here. Now I explained you what was samples, what was independent and dependent. Now your work is to identify whether these examples are independent or dependent samples. So take a look at the questions and tell me the answer. What about the first question? Just take a look at the sample size. Independent. Why? Because sample size is different. So for one population, you have N1. So I call that as N1 equal to 30. And for second population, you have as 32. So since they both are different, not equal, we call that as independent. What about example 2? Sorry, who was that? What's the answer? Independent? Yes. Why? Very good. This is independent sample. Even though the values are same, take a look at the data. They say it is smokers and non-smokers. Definitely they are not equal. Smokers not equal non-smokers. Yes. So even though the data is same, even though the value is same, the data is different. So you have to concentrate on both the value and the data. Okay. What about question C, part C? How? So you think it is independent? Okay. So both of them belong to one category, right? So you might say the values are same. Now, just going back to your dependent sample, just read the three sentences. So if you read, they say the sample values are paired or same or paired. So they are paired. Right? So this is dependent. Okay, why? Because it is a paired data. What about question 6? Sorry. Dependent, why? Again, it is paired data. And how can I see that? Here is the keyword. Okay, so this is paired data. So most of the time when it comes to dependent samples, you will have only one values given. Okay, this could give you some hint that this can be a dependent sample. Now, this cannot happen all the time, but most of the times. Okay, what about this? You don't even have to check the values. When it says husband and wife, that's a paid value. So it is definitely a dependent sample. Paired data. Okay, fine. Next is we are going to do a hypothesis test like we did in chapter 8, writing the null and alternative hypothesis, finding critical value, test statistic, and then making an initial conclusion and then the final conclusion. So we are going to repeat the same steps here in chapter 9. Okay. Now these are the notations because we have two samples. Now you will denote sample 1 with a subscript 1. Okay. Sample size. Population mean is denoted by mu. Sample mean is denoted by x bar. And standard deviation, we call that as S1 and S2. And the standard deviation is a sample. Okay. Now let's go to the steps here. Now these are the steps you have to follow. First thing is to check for the claim. Now you're going to write the null hypothesis. Null hypothesis will always have equal to symbol, and these three belongs to alternative hypothesis, where you will have less than, greater than, and not equal to symbol. Okay, you will be choosing any one among three depending on your problem. Okay, so after this, now these two are comparisons. Now, whatever you were doing in your chapter 8, you were comparing your population mean and you had only one hypothesized value, right? So you used to write like this: P equal to 0.6 or mu, which is population mean, equal to 0.6. This is how you used to write. Now here, when it comes to chapter 9, you know the value of another sample, so it would be like this, okay? Or 0.6 greater than 0.8. Now 0.4 greater than 0.1, something like this. So on either side, you will definitely have values. Okay, and you know it's very easy to compare when you have values. Okay, now after this, next step is to find the alpha. So you do not have to find that because it will already be given in your problem. Okay, now next thing is to find critical value, and after that you will be finding p-value, which is the area, and you can use TCDF in your calculator, and after that you will be using the statistic. Okay, because this is like this. First test statistic and then you find p-value. Okay, now my question is, I said critical value and they are using t-distribution, and why is that? Okay, that's one person, and it is mean. Okay, so whenever you are testing hypothesis testing for mean, you will be using t-distribution. Okay, in other words, you will be calculating t-value instead of z. So nowhere in chapter 9 you will be calculating z values, you will be calculating only t values, both in critical value and test statistic. Right? Okay, so now after you find the p-value, next step is to make a conclusion depending on the p-value and alpha. So if they are less than or equal to alpha, you say reject H0. If it is greater than, you say fail to reject H0. Fine? And then based on that, you make a final conclusion. Okay. Now, instead of using this formula, the big formula here, you can use this one in your calculator. Whenever you want to find the test statistic or the t-value, you can use this steps in your calculator. Okay? Okay. So let's get to the example 2. Now, I'll just change or give the notations to this. I'll take this as sample 1. And this is sample 2. N1, N2, and this is sample mean. So I'll take it as mu1, mu2. Sorry, it's a sample, right? X bar 1, X bar 2, standard deviation S1 and S2. And alpha is given here, significance value. So I will take alpha as 0.01. Okay. So step 1, write the null and alternative hypothesis. So H0. Now it is talking about mean. So you see mu1 equal to mu2. So this is for all the problems. Okay, this is for all the problems. You will write null hypothesis in this way for all the problems of chapter 9. Okay. When it comes to alternative hypothesis, how can I make a decision here? A claim that blue enhances performance on a creative task. Okay, now you have to decide whether it is greater than or less than, but you do not have mu1 or population value, but the claim says it is blue enhances performance on a creative task compared to red. That means blue is somewhat greater, so it is increasing, so that means it is a greater than value. Now blue is greater than red. Or even if you take a look at this sample mean, you can easily see blue is greater. Now, how do you write that as your alternative hypothesis? Now, mu1 has to be written first. Okay? You cannot change the notation. You cannot write mu2 first and mu1 next. This is completely wrong. You have to write in an order, mu1 and mu2. Now, your work is to give a symbol here. It could be greater than, less than, or not equal to. Now, according to this, I know this cannot be my option. This cannot be the answer. Now you have to choose between greater than and less than. Now take a look at the value of sample mean. Blue is greater, that means red is small, right? Blue is greater, so red is small. So it is less than symbol. Red has to be smaller than, red has to be smaller than, less than mu2. Okay? Blue is greater than red. That means mu2 is greater than mu1. Okay? Now, if I want mu1 to be first, that means I'm going to change the place. Whenever you change the place, the symbol will change from greater than to less than. Okay? Okay. Next is you need to find the critical value or the t value. Now, how do you find the t value? You will have alpha, which is 0.01. Now, this is a left tail test because it is less than. So you will take alpha as it is. You will not be dividing it by 2. Okay. Now, what else do you need? You need degree of freedom to calculate t value. Now, degree of freedom, you know it is n minus 1. But here the problem is you have two n values. So which do you consider? Now what I do is I calculate 35 minus 1 is 34 df n2 minus n1. So I'll take it as df1 df2 and this is 36 minus 1 35. Now according to the steps given here, they tell you whenever you calculate a critical value, you have to choose a smaller df. Okay. Now here, if you compare your df1 is less than df2. That means this is smaller. So you will take df equal to 34. Okay. So you will put your df here, use your calculator and find the t value. Okay. Next, what you do is find the t value using the statistic formula, or you can also use a small here. So just go to stat, test, choose the second option, you get sample t-test, and from there you can calculate the test statistic value. Or you can also use t x1 bar minus x2 bar divided by s1 square divided by n1 plus s2 square divided by n2. Okay, so when you do this, you get a value of minus 2.05. Okay, you can also use in your calculator if you want to do in your calculator. So just go to test, stat, test, and you choose the option 2, and then you get your t value. Okay, now the answer for critical value of t is minus 2.441. Now just tell me I'm doing wrong. You get the same answer? This is your test statistic and this is your critical value. Okay. So once you complete doing this, next step is very simple. Find out the p-value. Your use TCDF. TCDF. Lower, upper. Yes, you also use DF. Then you use DF. DF also. In the p-value. So this depends on your test statistic value here. So this is a left tail test and it is minus 2.05. So, okay. So I have not really used it, but what is it asking for? Okay. Okay. So you must be, it has to be asking these values. And all these values are given in this table. You have to input two mean values and two standard deviation values and also N1 and 2.
Because it has, and then it has.
So it has mu symbol, X bar, and what else?
SX, and then your sample size.
N. Just try this value and tell me you get the same answer or not. Did you get the same answer? Check.
We should file a claim.
So you go to stats and then test and then true, right?
It was just X.
Yeah. It is asking you for x1. It is asking all the data. It is asking for n1, n2, x1, x2, sx1, xx2. You didn't get that? Yeah. Oh, that's number 4? Okay.
Okay.
Okay. It's number 4 then. And the name is 2-sample t-test. 2-sample t-test. You got it? Now, next is to find the p-value. TCDF is minus 10,000, or you can use minus 9999. Yeah, it is minus 2.05. And DF has 34. And tell me the p-value. Any values? Okay. Now, once you get your p-value, you're just going to compare p-value with alpha. Now you get p as 0.024 and alpha is 0.01. That's given in your problem. Now 0.02 is greater than 0.01. So p-value is greater than alpha. And then you make your initial conclusion here. Since it is greater than, you say fail to reject. H naught or null hypothesis. Okay, and then you make your final conclusion. So you have a small table in your chapter 8.2, you can refer to that. So it says there is insufficient evidence to support the claim. And you write the claim which is given the problem. That's it. Okay. So this is how you do when you have two means or two proportions. Okay. So this was your example 2. Okay. Now we have example 3, and I will leave this to you. Just calculate and tell me the final conclusion, or maybe initial. Okay, so you write null hypothesis mu1 equal to mu2 and h1, mu1 and mu2. Now you have to write the symbol. So for that, you go to the question and the highlighted one is the claim. So how do I know that? Because you have a word here, claim, and after that, whatever comes will be your claim, right? Now it says it is greater than the IQ score of low hat, that is a sample 1 is greater than sample 2. So if sample 1 is greater than sample 2, what is the symbol? Greater than. Okay, according to the claim, sample 1 is greater than sample 2. So we write like this. Okay, next is to find the critical value, the t-score. So you have the area as 0.05. df is your degree of freedom, that is n minus 1. So since sample 2 gives you the smaller df, so we use 21 minus 1, which gives you 20. That's why I have 20 here. Now, what is the value if you calculate this in your calculator? 1.725, and it's negative. Okay. So what about the statistic t-value? Right. 2.282. Now you need to calculate your p-value. You use 2.28 as your lower value, 2.282. Upper value will be 99.99, or you can use 10,000. And it's negative 1.725. Are you sure? So this is a right tail test because it is greater than, so area will be here, 0.05. Now, if you want to calculate the t-score, you do 1 minus 0.05, right? Okay. So this is your upper value, and then you give df as 20 here. So if you do this, what is the value you get? 167. Okay. Now you have p-value, you have alpha, which is 0.05. So when you compare this 0.0167 with 0.05, p-value is less than alpha. So you give p-value less than alpha here. So what is the initial conclusion? Reject H naught. Now you are rejecting H naught and your claim is H1. So according to the table, you see there is enough evidence, sufficient evidence to support the claim. And you write whatever the claim is mentioned in your question. Okay, so this is how you have to do the whenever you have two samples, this is how you do. Okay, so there is a small portion left, just finding out the confidence interval. It's very easy, and there's only one example. So I guess I will do this in the next class. So this is the continuation of section 9.2, chapter 9. So we did complete example 3, and so now we will see how to calculate the confidence interval. It is just like one step extra. So this is what you will have x1 and x2 given. You have to find the margin of error. This is the only term you have to find. And to find margin of error, you have this formula. Okay? And this is how we find the confidence interval. So you can also do this with a calculator. Go to stat, test, and you can just click on the second button. And this is for TI-83. I'm not sure if the steps are same for TI-84. Okay, so you can use sample t interval int, and then you just have to mention the confidence level, and then that will give you the confidence interval. So this is one way of doing in the calculator. Okay. So we will straight away go to the example. We just have one example to do. Now, using the sample data or the data given in example 3, we are going to construct the confidence interval. Okay. So I'll just write the data given in example 3. You can go back and check the data. That's also fine. Okay. So to find the confidence interval, we need x1 bar, x2 bar, right? So according to your example 3, in the given data, this is your x1 bar, 86.90476. Okay, and then you need to find your margin of error, that is E. To find E, you need alpha, S1, S2, N1, and N2. Okay, I will give you all the data here. This data is from example 3 of the same section. So S1 is equal to 15.34451. S2 is equal to 8.988352. N1 equal to 78. N2 equal to 21. And we have also calculated T alpha by 2 in the previous example, and that is 1.725. Okay, so in example 3, alpha was 0.05, degree of freedom was 20. Okay, so you have all the data you need to calculate the confidence interval. Plug those values into the formula and calculate and tell me the answer. Did you get the answer? Okay. So if you have plugged it correctly and did the calculation right, your answer must be 4.519963. This is for margin of error E. Okay. And you're going to do the same thing here, plugging x1, x2, and E. So this has to give you 1.5 less than mu1 minus mu2 less than 10.5. Okay. Now, the question says you have to construct a confidence interval, and we did that. It is also asking to test the claim. That means we are supposed to write the initial conclusion and final conclusion. So, in our previous sections, we saw that we used to calculate p-value, alpha, and we are supposed to compare those two. And if it is less than, we are going to reject H naught. If it is greater than, we say fail to reject H naught, right? So how can we make a conclusion when we have a confidence interval? Okay, so this is a bit of confusing, but if you can understand, you can easily do that. Okay, so you know that mu1 minus mu2 is what you are going to calculate, right? And you will have two numbers on either side. Two numbers on either side of the confidence interval. Now, if these two numbers are positive, or if these two numbers are negative, then we say reject H naught. Okay, reject H naught. Now, what if the symbols are different? If mu1 minus mu2, if the symbols are different, like negative, plus, or say plus, negative, negative, plus, or it could be plus and negative, then we say fail to reject H naught. Fail to reject H naught. Okay. Now, according to this, both are positive. So the initial conclusion will be fail to reject, so reject H naught because both are positive. Okay, so this is how you conclude the or test the claim. So this will complete your section 9.2. Now we will start with another section, 9.3. Now, what did you do in section 9.2 was calculating or testing the claim for two independent samples. Now we will be doing the same thing, but this time we will have two dependent samples instead of independent. Okay. Now, these are the notations we use in this section. D is the individual difference. The meaning, we will have two, right? When there is a two samples, we will have two things. Could be a sample size, mean, or could also be a standard deviation. Everything was true. So when it comes to two dependent samples, we will take everything to be 0. Okay? Because according to two dependent samples, we assume all the values are same. So when you subtract the same values, you get 0, right? So your null hypothesis looks like this. Okay. Now, this is what you do in the calculator. First, you will have two values, right? You're going to plug those values into the calculator and compute d. D in the sense difference. That means you're going to subtract those two columns. Okay, this is what you do in the calculator. In step 2, you find d bar and st. St in the sense standard deviation. Okay, and you can do that by stat calculator, and you can choose the option 1, and it will ask you to choose the column, and you're supposed to choose the D column. Okay, so in your calculator looks like this. You will have L1, L2 and L3. L1, L2 and L3, and this L3 is nothing but L2 minus L1 minus L2. Okay, and we call this the L3 column as D. Fine. This is what you do in your calculator, and you will see why you have to find the mean and standard deviation. Now, coming to the hypothesis testing, we follow the same procedure as we did in chapter 8 and the previous section. Now, always you write null hypothesis in this way. Okay, always. It could be for any example. Always we write null hypothesis equal to 0 for two dependent samples. So when it comes to alternative hypothesis, you will have three options. It could be less than, greater than, or not equal to. So what you have to observe here is you don't have to write any values. Okay, you don't have to write any value. Always for dependent samples, it will be 0. Okay, now once you write your null and alternative hypothesis, next step is to calculate the critical value. So you do this as usual you did for chapter 8 and previous section, and then we go to test statistic and calculate the p-value. Then comparing with alpha, we make our conclusions. Okay, this is what we did in previous sections, right? Okay, so these are the steps. Now you can also calculate t-value using this stat, test, and t-test, and you're supposed to use the data with the list D. Okay, so now that you know how to do, we will see one example. Okay, so we have example 1 here. Now let's assume that we are not doing section 9.2 or 9.3 specifically. Okay, now I'm telling you, I'm just giving you this question randomly. Now, how do you calculate or how do you test the claim? Because you do not know whether it is independent or dependent. For independent and dependent, the procedure is same, but the formulas are different. So your first task is to identify whether it is a two sample hypothesis or not. Okay, now depending on the data here, I can say it is two samples. Now my next work is to identify whether it is dependent or independent. Okay, now I told you for independent and dependent, sample size will be different. And for dependent, sample size is same. Now when I mean sample size, I'm not talking about the values here, I'm talking about the sample size, how many number of samples are present. Okay, so that's how you have to classify. That's one thing. Or if you have a large data and if you cannot count the sample size, you have to observe the data given. Okay, now it says before, after. If you have something like a paired data or a matched data, then you can easily conclude it belongs to dependent. Okay, so this is how you have to think. Fine. Now that I know it is a dependent data, I will follow the procedure. Okay. Okay. So my first thing is to calculate the difference L1 minus L2. Now you can just put this entire column in your calculator and calculate the difference, or if you are good at math, you can calculate by hand. 3, this is going to be minus 1, this is 2, and this is 0. Okay, now once you calculate the difference, next step is to find the mean. Now again, you can use the calculator. You can go to stat, cal, and then you can just choose option 1. There you are going to choose the D column, and that will give you the mean and standard deviation. I'll give you a minute to do that, and then I will write the answer. Let me write it here. Stat, cal, and you have to choose option 1, that is one variable stats. Okay, so in this you're going to input D. So you can do this, or you can calculate by hand. So it is 3 plus 3, which is 6, plus 4 is 10, 10 minus 1 is 9, 9 divided by total number is 6, that gives you 3 3s are 9, 3 2s are 6, that is 3 by 2, and 2 1s are 1.5. Okay, so you can do this with the help of calculator. So when you do with a calculator, you will get mean and standard deviation both. Fine. So just check the answer. D bar has to be 1.5. Standard deviation must be 1.643. Now we know that sample size is 6 and degree of freedom is 5. 6 minus 1 is 5. N minus 1, 6 minus 1, which is okay. Now once you get the basic data, you can go ahead and calculate or test the claim. The first step is to write your null hypothesis. H naught, that is mean of the difference, is equal to 0 always. And H1, mu of the difference, is 0, but I do not know whether it is greater or less than or not equal to. Now, even if you concentrate on the data given, even if you read the question, there is nothing which is specifically mentioned, right? The claim is to check the number of errors, and that errors has to be reduced. Okay, so there is nothing given whether it is greater than or less than or not equal to, nothing. So how do you decide, or how do you give the greater than or less than symbol? That depends on the data. Okay. Now we know that we are looking for mean value. Now, what is a sample mean? Sample mean is 1.5, right? If a sample mean is 1.5, then population mean should be more than that, right? So this is a positive value. So definitely a population mean will be positive, that we know. So if you want something to be positive, that has to be greater than 0. Agree? Agree to this? If you have a number line, it starts from 0, 1, 2, 3, and this is going to be -1, -2. So all the values here is less than 0. All the values here is greater than 0. So if your sample mean is positive, then you are going to put greater than symbol here. Okay, so this is how you have to conclude. Now you have to learn and practice till here, because depending on this symbol, you do all the calculations. If this goes wrong, then your entire solution is wrong. Even if you do with a calculator, you cannot get the right answer. Okay, so make sure to get the symbol right. Now that we know it is greater than, that means it is going to be a right tail. Your right tail test. So the area is somewhere here, and alpha is mentioned, that is 0.025 given in the problem. So alpha equal to 0.025. Okay, now your work is to calculate the t-value, because you are working with me, so you need to find the t-value. Okay, so second step is to calculate the CV, critical value of t. Now that you know, you can use your calculator, t of area and degree of freedom. So t 0.025, degree of freedom is 5. Input this and you will get 2.57. Okay, you have to use inverse t. Since it is to the right side, we do 1 minus area, comma, degree of freedom. Okay, and once you do this, next is the statistic t. So the formula is d bar s divided by square root of n. Now d bar is 1.5 given, or you have calculated. SD is 1.64, 1.643 divided by square root of n is 6. So whenever you do this in your calculator, calculate the denominator first. Okay, and then say you get how much do you get when you calculate this, the denominator? 1.64 divided by square root of 6. 0.67, right? So it is going to be 68. How much do you get? Yeah, the total answer. Right. Okay. So once you calculate the test statistic t value, you have to calculate the p value. So you can use TCDF in your calculator. Lower number is 2.24. So whenever you have a right tail, this will become your lower. And upper you do not know, so you just put it as 10,000 or 9999, some large number. And then your degree of freedom, that is going to be 5. So if you do this, how much do you get? Yes, 0.0376. Okay, so this is how you calculate p-value. And next step is very simple. You're just going to compare p-value with alpha. Now we know p is 0.0376 and alpha is 0.025. So it is 0.02 on the right side. Left side we have 0.03. So it is 0.01 difference. So it is greater than. Okay. Now p-value is greater than alpha. So your initial conclusion has to be fail to reject H naught. Okay. So this is how you have to do. Okay. So next is your confidence interval. So like you did for in the previous section, I mean the 9.2, you have a formula there. So instead of x1 and x2, this time you have d bar. That's the only difference. Okay. So you will have d bar. You have formula to find E, and you can easily find the confidence interval. Now we are using data from example 1, and we know that difference is 3, 3, and it is -1 here, 2, 2, and 0. Okay. Now you need to find d bar that we did in example 1, which was 1.5. And what else do we need? We need SD, and that is 1.643. Now this data is from example 1. You can do it again. N is equal to 6, df is equal to 5. Now your work is to calculate what is d alpha by 2. Now alpha is given, it is 0.025. So you put 0.025 divided by 2 with df. Okay, and you find t alpha by 2. So that's one thing you need to find, and then you're going to substitute this in E. T alpha by 2 st divided by square root of n. Okay, you have all the values. All you need to do is plugging in. Okay, now once you find these two, your final has to be this: mu difference less than p bar less. Do this and tell me the final answer. You can do this, or in your calculator you can, this is in your calculator, you can go to stat, test, and t interval. So if you're doing in your calculator, it will ask you for confidence level. So confidence level here in this example is not given. So if the confidence level is not given, if not given only, you can take confidence level to be equal to 2 into alpha. You know alpha, which is 0.025. Just plug this and calculate. Or you can also do in this way. Done. Okay. So check if your answer is correct or not. So your T alpha by 2 must be 2.571 and E is going to be 1.723. You're just going to plug this here. So D bar is 1.5 minus 1.723 less than, and D bar is 1.5 plus 1.723. So when you do this, you get 0.223 less than mu difference less than 3.223. Now, all you have to observe is with the sign, this is minus, this is plus, you have a different sign. When you have a different sign, your initial conclusion will be fail, reject, H naught. Okay, so this will end your chapter 9, and on Monday we will do chapter 10. So do you have any questions till now? No? And I guess your test 3 will be in couple of weeks. So you have to study from chapter 7, 8, and 9. So till chapter 9. Okay. So I will give you a small note here so that it will help you when you're doing your cheat sheet. So this is for chapter 9. A small note. I'll just summarize whatever we did or whatever we studied. Okay. So chapter 9 was all about two things: independent and dependent. Okay. And you know what are the steps to test your claim. So chapter 8, chapter 9 is about only one thing: testing claim and making a final conclusion. Okay. When it comes to chapter 9, we have two things. We have two different things: independent and dependent. Okay. So first task for you is to identify whether it is independent or dependent. So if your sample size, I'll just write it as n. If n1 is not equal to n2, then we say it is independent. If n1 is equal to n2, it is dependent. Okay. Now, once you know this, in independent, you will write your H naught. So that's your null hypothesis. So when it comes to independent, your mu1, if you are working with mean, mu1 will be always equal to mu. Now this is for any problem. Okay. Next is H1. Now your H1 will have three symbols: less than, greater than, or not equal to. Again, this depends on the problem. So you will have a claim given. If the claim says greater than, you just write greater than. Okay. Now that we are clear till here, this is the first step. What is the second step? Is to find the critical value. But we know that there is no use of finding critical value because we just use the statistic to find the p-value. Okay. Now, still, to find the critical value, we use inverse t of area, comma, degree of freedom. Fine. So area is nothing but the alpha, whichever is given. df is the degree of freedom, and the formula for df is n-1. So when it comes to two samples, we have n1, n2. Whichever is smaller, that will be your df. Okay. Now we are okay till here. Next is to find your test statistic. Now we have a formula to find the test statistic, or you can also refer to your calculator. Let me give you the steps. Okay. So if you are going to do with the formula, you have x1 minus x2. These two are the sample mean, divided by square root of s1 square plus s2 square, divided by n1, n2. This is the formula we use. Or you can also use stat, test, and we use number 4, right? Number 4, that is sample t-test. To sample t-test. Okay. So once you find the test statistic value, next step is to find the p-value. P-value. Now we use calculator, CDF, lower, upper, and then you just mention the DF. Okay. Lower and upper value, if you're getting confused, in chapter 8, in the last section, I have mentioned for left tail and right tail for no tail, what you have to take as lower and upper. Okay, refer to that also. Now, once you're done with that, last step is to compare your p-value with alpha. It could be less than or equal to, or it could be greater than, any two. Fine. So based on this, you make an initial conclusion and final conclusion. Okay. So these are the steps you're supposed to do in chapter 9 and also in your chapter 8. Okay. So this is for independent. Next is dependent. It's the same thing. So I'm just going to dependent and just going to copy the whole thing here. Okay. Now, when it comes to dependent, these are the changes. Mu1 and mu2, we don't have two things. So it is going to be only one thing, that is mu d. Okay. And what is it equal to? It is equal to 0. Always. Okay. Now again, as I told you, there is no 1 and 2. When it comes to dependent, all we have is d. D for dependent. Okay. When it comes to dependent, your H0 and H1 must have a D. Fine. Now again, you will have only three symbols: less than, not equal to, and greater than. Again, this depends on your D bar value. So you know mu difference has to be, so when it comes to dependent, there is only 0 value. Okay. Now, how do you decide whether it is less than or greater than or not equal to? It depends. So let me write here. So sign depends on the claim, but if the claim doesn't specifically tells you whether it is more, reduce, anything like that, then it mainly depends on d bar value. Okay, if d bar is positive, then mu d is greater than 0. Vice versa, if d bar is negative, mu d is less than 0. Okay? And it's a rare case that you get a not equal to symbol. Okay, so once you are done with that, the second step is same. No change in the second step. Now, only change is with a deer. You have only one deer, so you don't have to compare, or you don't have to take a smaller one. So once you are done with that, next thing is to find a test statistic. So to find a test statistic, this is the formula. Okay. So it is d bar divided by st divided by square root of n. Okay, or you can also use stat test, but this time you use t-test. T-test. Okay, and p-value, it's the same thing, lower upper tier. Lower upper depends on the right tail or left tail. Fine. And next is just comparing your p-value with alpha. If it is less than or equal to, you say it is reject H0. If not, you say fail to reject H0. Let me write that here. Reject H0, and here we say fail to reject H0. Okay, so this is a summary of chapter 9. Very small, very short. So you just have to know which formula to use depending on the problem. So all you have to identify is whether it is a 2 sample or 1 sample. That's very easy. And once you identify it as a 2 sample, you have to identify independent and dependent. That might be slightly confusing, but if you just concentrate on the sample size, that is also done. Fine. So this will complete your chapter 9, and we will continue on Monday.